All right, so this video we're going to go over the first part of 2.4. So that is dealing with finding zeros of polynomial functions, which we've done before, but this will involve something a little bit different. So first thing is the fundamental theorem of algebra. So that says a polynomial function of x with degree n has exactly n zeros. So whatever the degree is, that's how many zeros there are, okay, real and non-real. Some of those zeros may be repeated. So the degree matches the number of zeros. For factoring, if f of x is a polynomial function with degree n is greater than 0, then the function has precisely n linear factors. Okay, so that says the same thing. So the number of factors equals the degree, okay, which also equals the number of zeros. So all of those things can mean the same thing. Okay, so the degree tells you the number of zeros, which also tells you the number of factors. Okay, three statements, if you have a polynomial function, three statements that all mean the same thing. So these would all be equivalent. If you have x minus k is a factor of f of x. Oops. So let's just say x minus k is a factor. So k is just a number. X minus 2 or whatever is a factor. Then x equals k is a 0 of the function. Okay, so the factor and the 0 would be opposites of each other. So like if it said x minus 2, then x equals 2 would be a 0. And then the third thing, f of k equals 0. Okay, so that means if you plug in a value, it makes the function equal to 0. Okay, so that would be plugging in that number. So in this case, that would be 2. If you plug in 2, you get 0. Okay, so all three of those things are the same thing. They are all equivalent statements. Okay, so some connections. Suppose that f of x is a polynomial function with real coefficients. If a and b are real numbers with b is not equal to 0, and a plus bi is a 0 of f of x, then a minus bi is also a 0. So these pairs are called, maybe you remember this from Algebra 2, those are called the conjugate. Okay, so just next to this, I'm going to write non-real zeros always come in pairs. Okay, so just remember that. That's going to come up. So non-real zeros always come in pairs. So it always has a conjugate. Okay, so we're going to do finding polynomials with complex zeros. So everything we've done so far, we've just been looking at the real zeros. Now we're going to do complex. So we want to write the polynomial function in standard form. So this means multiply it out. Okay, we're going to multiply everything out. And then identify the zeros of the function. Okay, so if you're going to multiply all of this out, we're just going to distribute everything, right? So it doesn't really matter what you do first. I would suggest, so you have x plus 2, you have x minus I root 3, and then you also have x plus I root 3. I would suggest multiplying the things with the i's, because then maybe some things will cancel and then you don't have to deal with as many. So I'm going to do those last two first. So I'm going to distribute x times x. That's x squared. X times I root 3. It doesn't really matter how you write that. I'm just going to put the I first. So ix and then a root 3. You could write xi root 3. That's fine. And then we have minus ix root 3. And then multiply the last ones. So that would be minus, here, let's do this off to the side. I root 3 times I root 3. That would give us an I squared, right? I times I is I squared. And then root 3 times root 3 would be root 9. Well, the square root of 9 is 3. So this becomes 3i squared. Okay, that's just that first part. Now, if we simplify that first before multiplying the last part, let's do that. So I have a plus ix root 3 and I have a minus ix root 3. Those are going to cancel. And then also think about what you remember from algebra 2 about I squared. I squared is -1. So let's simplify this a little bit. So this becomes x squared, nothing in the middle. And then it's minus 3 times -1. So that ends up being a plus 3. Okay. Now you do still have this x plus 2 that was hanging out in the front. So I'm going to bring that down. So again, we're multiplying everything out. Now we just have a little bit of a smaller thing to multiply. So x times x squared is x to the third. X times 3 is 3x plus 2x squared plus 6. Okay, so I can rewrite that so it's in standard form. I'm just going to flip-flop these two things. So that's x cubed plus 2x squared plus 3x plus 6. Okay, so that is taking the factored form and writing it in standard form. So again, just multiply it out. And then we also want to write the zeros out. Okay, so remember, zeros are just the opposites of all the factors. So the zeros, if I had x plus 2, then my 0 would be -2. Now the other one says x minus I root 3. That means that one of my answers is positive I root 3, and then the other one is negative I root 3. And so you could also write that as plus or minus I root 3, but again, it's just the opposites of your factors. Okay, so standard form just means multiply it out. All right, so let's go to example 2. So we want to find a polynomial function of minimum degree in standard form, so again, standard form, with real coefficients whose zeros include the following. Okay, so now this one is giving us the zeros, so we're like going from this part, and we need to write the factors. Okay, so adding a little added extra step. So let's write down next to this what our zeros would be. So for our factors, sorry. If -3 is the 0, so let's go back up here. So like this, if that's a solution, then we write the opposite as the factor. So if if x equals -3, the factor would be x plus 3. Okay. For positive 4, that factor would be x minus 4. Okay, now when we write the conjugate, oh man, I just said it again. When we write a complex one, we're going to write x minus 2 minus, I. Okay, because that's the first one. But then remember, these come in pairs. So actually, there's another one that is at 2 plus I. Okay, so that one we also have to write in there. So this would be x minus 2 plus I. I'm going to put that in parentheses because I'm subtracting that whole thing. Okay, so that's kind of the only trick here. Remember, complex numbers come in pairs, so you do have to include the conjugate as well. Okay, so let's go ahead and multiply these out. I know there's a lot of things here. So maybe let's clean up these first, the last two first. So this would be x minus 2 and then plus I. Okay, and then you also have x minus 2 minus I because we should distribute the negative signs. Okay, and then we still have x plus 3 and x minus 4. Okay, so now our job is just to multiply all those out. So again, I would probably start with the things with the i's, and hopefully some things will cancel out. So let's do x times x, that's x squared. X times -2, that's minus 2x. And x times -I. So that would be minus ix or xi, it doesn't matter. Now let's distribute the -2. -2 times x, that's minus 2x. -2 times -2, that's plus 4. -2 times -I, that's plus 2i. All right, I might run out of room here. Then the last part, so I times everything. So I times x, I times -2, And then positive I times negative I, that's minus I squared. Okay, that was a lot. Let's clean that up. So look for anything that might cancel. So I have a minus ix and a plus ix. And then I have a plus 2i and a minus 2i. Okay, remember I squared is negative 1. Now there's a negative in front of that, so that'll become a plus 1. I think that's all that will cancel, right? So then look for any like terms. So I do have an x squared. There's a minus 2x and another minus 2x. So that would be minus 4x. And then there's a 4 and the plus 1. So that would be plus 5. Okay, so that's all from those last two factors. Now you still have the x plus 3 and the x minus 4. So maybe it doesn't matter once you're multiplying. You can multiply in any order. Maybe let's just multiply these two. So this would be x squared minus 4x plus 3x and then minus 12. So that ends up being x squared minus x minus 12. All right, we're almost there. And then you have the x squared minus 4x plus 5. One more time of multiplying. So x squared times x squared is x to the 4th. X squared times negative 4x, that's minus 4x to the 3rd. X squared times 5, that's plus 5x squared. And then do everything with the negative x. That's minus x to the 3rd plus 4x squared. And then minus 5x. And last but not least, do everything with the negative 12. So that's minus 12x squared plus 48x, right? Negative 12 times negative 4x. And then negative 12 times 5 would be minus 60. Oof. Okay, so we're almost there. Now it's just clean up your like terms. So I have an x to the 4th. As far as x to the 3rds, let's see, I have negative 4x to the 3rd minus x to the 3rd, so that's minus 5x to the 3rd. For squareds, I have 5x squared, 4x squared, and negative 12x squared. So 5 plus 4 is 9. 9 minus 12, that's minus 3x squareds. And then we have our x's. So negative 5 plus 48, that's plus 43x. And then lastly, we have our minus 60. Okay, so that is writing that all out in standard form. So yes, it takes some time, but it's just multiply everything out. Okay, and then again, just don't forget that complex numbers come in pairs. Okay, so that's all that really is. So example 3 is really the same thing. I'm not going to maybe do this whole thing, but just for time's sake. Now this one says x equals 1 multiplicity of 2. So if you write that as a factor, that's x minus 1. Multiplicity of 2 means it's happening twice. Okay, and then you have another one that's complex. So you would write x minus 1 minus I. And then we would also write 1 plus I, so x minus 1 plus I. Okay, and then you could do all that multiplying again and see what works out. But that would be how we would start that one. Okay, so those are the big things. The next part is factoring with complex zeros, so actually doing the factoring part. We're going to do that in the next lesson. So I'm going to stop here, and then you have a lesson check that you can do for this lesson. Okay? Let me know if you have any questions tomorrow, but you have the practice on this now. Okay? Thank you.